In this video, we're going to cover all the content from the AQA specification for energy transfers. We'll look at energy conservation, energy dissipation, reducing heat loss and efficiency. That's everything you need to know in 5 minutes. The law of conservation of energy tells us that we cannot create or destroy energy, only transfer it from one store to another. This means that within a closed system where there are a set number of objects, the total energy stays the same. In this example, I've got a ball on a string. If I pull the ball up to one side, I'm using a force to increase the gravitational potential store of energy of the ball. When I let go, the store of energy of the ball changes from gravitational potential to kinetic as the ball's speed increases. As the ball moves up to the other side, the kinetic store decreases and the gravitational potential store increases again. Throughout these changes to the ball, the total energy stays the same, it's just stored in different forms. In reality, we know that the ball will eventually slow down and stop swinging, but the energy can't be destroyed, so where has it gone? You need to remember that there is another object in this system that is interacting with the ball, and that's the surroundings, in this case, air particles. In all systems, we get energy being wasted and spread out to the surroundings. In this case, as the energy stored in the ball decreases, the thermal store of energy of the air particles increases. We say that the energy has dissipated. Energy can also be dissipated to the surroundings by a force. In the case of a child on a slide, friction does work that transfers some of the gravitational potential store in the child to a thermal store of energy in the slide. This is a really common way that energy is wasted in systems with moving parts. We can reduce the amount of energy dissipated by reducing friction. For example, the child could sit on a sack like you do on a helter-skelter, or we could even put a lubricant like washing up liquid all over the slide. In both cases, less energy would be wasted, meaning that more energy can be transferred into the store that we want, the kinetic store of energy of the child. You need to know a little about how to reduce unwanted energy lost through heat transfer. If I have a cup of tea in a metal cup, the thermal store of energy of the tea will reduce quite quickly, with the energy being transferred outwards to the surroundings. It happens quickly because metal has a high thermal conductivity. I can use insulation as a way of stopping energy being dissipated. If I wrap my mug in a nice knitted wool jumper, it would reduce the rate of cooling, because wool has a lower thermal conductivity than metal. We can use this idea in our homes to stop too much energy being dissipated to the outside in winter. The walls of our homes can be made to be thick, with several layers, and using insulating materials that have a low thermal conductivity. When energy is transferred, some of it ends up where we want it to be, in what we call a useful store, and some of it ends up somewhere else. We say it's wasted. Efficiency is a way of comparing different systems and how good they are at turning the energy we put in into useful stores. Efficiency equals useful energy out divided by total energy in. You can also work it out in terms of power, useful power out divided by total power in. This equation will give you an answer between 0 and 1, and if you multiply your answer by 100, you'll get a percentage. In both of these circuits, there is 100 joules of energy being input from the battery. The old-fashioned style filament bulb transfers 40 joules into useful energy, which is an efficiency of 40 divided by 100, 0.4 or 40%. The energy-saving light bulb, in comparison, converts 60 joules into useful, so it has a higher efficiency of 0.6 or 60%. To increase the efficiency of a transfer, we need to reduce the amount of wasted energy for the same input amount. And we've just talked a few minutes ago about common ways to do that. Thanks for watching, I hope you found it useful. Download a copy of the notes from this video on my website, missbroom.co.uk. Get daily updates and your questions answered on my Instagram and Facebook pages. And to help other people find these videos, please hit like and subscribe.